Oh my goodness.
What's he doing?
I just went out of it. It's fine now. Okay. All right. Are you guys done with number 2? Is that enough time? That was enough time. You said 5 minutes. Okay. Solve the inequality. This is something you guys learned last Thursday? Last Wednesday? One of those days. But just like solving an exponential equation, it's just this time we have an inequality. So, what do we always need to do first? Get the same bases? Yeah? No? Oh, that's not what I wanted. There we go. Okay. Get the same bases. So what did 27 and 9 have in common? 3. All right, so how do we rewrite 1 over 27 as a base of 3? Not just 3 to the third, but how do we get a fraction again with an exponent? -3. So 3 to the -3rd. So this is 3 to the -3rd. Keep the same exponent. And then sign stays the same. How do we rewrite 9 as a base of 3? Not 9 squared, but there you go. 3 squared to the 5x. All right, and then now that we have the same bases, we distribute in our new exponents. So we get on the left side 3 to the, oh, that's really hard to see. 3 to the what? On the left side? -3x minus 39. All right, and then less than or equal to, and what we get on the right side? Not just 5x, 10x, there we go. All right, we have the same bases, right? And our exponents are all nice and neat. So we cover up our bases. And if I had more room, we would drop down our exponents, right? But I'm going to do it over here. So -3x minus 39 is less than or equal to 10x, right? All right. What do you do first? You want to get, what'd you say? Not just subtract 3, add. Yep, we always want to do add, opposite sign. So we add 3x. So we get -39 is less than or equal to, what's on our right side? 13x, and then do what? Divide by 13. All right? What do you get on your left side? Not just 3, -39 divided by 13. -3, there we go. All right, so x is greater than or equal to -3. Everyone feeling okay about this? Again, this is just review of exponential equations and inequalities. Something we've been doing for the past 4 days. This will be on your test, so, which is next Thursday, the 16th. We finally decided on the date. We forgot to talk about that yesterday. Sorry about that. But it's the 16th, not the 14th anymore. So we're not having it on Valentine's Day. So it's next Thursday. Okay. But anyway, yeah. Okay, cool. Get your workbooks out. We're going to be in page. Can I go past this? Okay. Change slides. We're going to be on page 365 today. So page 365 is part of 7-2, which we started last week when we started talking about solving exponential equations and inequalities, because that is a part of 7-2. But there is another part called compound interest. Has anyone ever heard of compound interest? A little bit, yeah? So I'm going to be real honest with you. Compound interest was not my favorite thing in Algebra 2. But we're going to get through this together. The cool thing is this is a very applicable piece of Algebra 2, okay? A lot of, I don't even know who uses this, but accountants,
Savings accounts.
finance people, so if you want to go into anything to do with money, you're
Or
going
doing
to use this
math.
for the rest of your life. So even when you, loans use this. So if you decide to go to school, college, you have to take out loans, you have to take out a loan for a house or a car, you're going to use something like this, okay? So very applicable. But I know that this is going to be a little just different, so it's okay. We're going to take the whole week to continue coming back to this. Luckily, we're given this beautiful formula. And you will be given this on your test. And so it just says A equals P times 1 plus R over N times, or to the NT power, okay? So each piece of these has something, it has a real world meaning. A lot of these problems are going to be word problems. But we're going to work through them, so you will be able to know how to pick out which piece is what variable, okay? So A is the amount in the account after T years, okay? So A is what we're typically solving for. Sometimes we're given A and we have to find the principal or we have to find the interest rate. Sometimes you're given A and you are going to find another piece. But typically, as we start out, A is what we're going to be solving for, okay? T years, so T is in our exponent. That is just the amount of years that is given to us. So if you have your bell workout still, we'll continue to kind of refer back to this, but we'll actually solve it later. But looking at your bell work problem, which I just put back up, what do you think? Yeah, what do you think T would be? Reading through this. T is the amount of years. What do you think T would be? Four, yeah. Because it's asking us in part B how much money will be in the account after 4 years, right? So that's what T is going to be. The next piece we're given, P is the principal amount invested. So P is kind of, I'll just go back to bell work, that's easy to refer to. P is the principal amount. So in this case, so it's the beginning amount in an account, it's the beginning amount someone invests in something, it's the beginning amount of the loan taken out, things like that. What do you think P is in this problem? $3,000, yep, exactly. So P would be our $3,000 in this instance, okay? And then we have the 1 plus R over N. R is our annual interest rate. So key word here, R is the annual interest rate, okay? So and then N is the number of compounding periods each year. So if you're asked to find, after 1 year, how many, or for an annual compound, what is N going to be? If it's the number of compounding periods each year. Not 12, because if we're asked to find annual compound interest, that means we're going to be asked to find for 1 period, which is the 1 year. Does that make sense? So that's when N is just 1. Which we'll go through a problem like that, just so you know. But R, in the bell work problem, what is R? R is our annual interest rate. Yeah, 3.8%, okay? And then N in this instance would be 1 as well, because it's asking after 4 years. But this one doesn't really say, but I'm pretty sure this problem was supposed to say something like with periods of an annual for a full year, okay? Sometimes you'll get questions like this where you're just gonna have to Yeah. Which is what it says in the annual interest. Okay. So does this equation make sense? Okay. It's pretty standard. We're just going to be given a lot of the pieces and plugging them in. Okay, sometimes we're going to have to use like intuitive sense to find some of these pieces, which we'll see in a little bit as well. So if you flip to page 368, we're going to be hopping a little bit around. Page 368, we're going to be going through example 3 first, okay? So Luciana deposits $1,700 into a savings account that pays 1.8% annual interest compounded monthly. What will be the balance after 5 years? What is 1,700 mean? What piece of the equation is that? And your equation's given right here. There we go. P. Yep. $1,700 is P. Okay? What do you think 1.8% annual interest is? Which piece is that? R. So this is our R. And then what is 5 years? Did you see? T. Yep, awesome. 5 is our T. And then it says compounded monthly. Which piece would that be? N. Yes, that is our N. So N is going to equal what? It's how many periods are in a year. So if it's compounded monthly, how many periods are in a year? 12. And it's going to be 12. Does that make sense? So if it says compounded annually, N is going to be 1. If it says compounded monthly, N is going to be 12. Okay? So what will the balance be after 5 years? So we can plug in our P, which we know is $1,700. So $1,700 goes here. And then it fills in the rest for us. But we already kind of figured out what R and T are. What do you notice about this equation, specifically about our fraction here, R over N, that looks different from the numbers we were actually given? The decimal, yeah. We have to take our interest percent, or our interest percent, our rate, which is always, not always, most likely going to always be given in a percent, okay? But we have to take this and put it into a decimal, okay? So 1.8%, how do you change it to a decimal? How many decimal places do you go? 2, yep. So 1.8, and then to change it to a decimal, you go 1, 2 to the left, which is why we get 0.18 here. Makes sense? So what? What'd you get? Yeah, awesome. Yep, so if you plug it in your calculator, a couple things about plugging this in your calculator. All right, when we plug this in, Dr. already got the right answer, which, what'd you get? .97, yep. Typically, you're always going to round to two decimals because we're talking about money here. So 2 decimals is a good place to always round to, okay? But when you plug this in the calculator, a couple things to remember. So you type in your 1,700, and then in your parentheses, you type in 1 plus, and then, sorry guys, I'm getting used to scientific calculators, so I've really never used these that often. You can type 1 plus, and then there's an ND. The N over D, it's right next to...
Second column, third one down.
Yep, there we go. Second column, third one down. And you can get a fraction. You guys see that? N over T, right there. So, yeah, exactly. And you can get a fraction to type in your, what do we have? We have 0.018 and then over 12. So, you're gonna, to get out of the fraction, you're gonna click the arrow, the next arrow. Yeah, does that make sense? Okay, perfect. And then don't forget to close your parentheses. And then when we take it to the power, key thing here, this is not 12.5, right? I heard from another teacher that was something their classes were struggling with. We're multiplying 12 times 5. So if it's easier for you to, before you plug this in, to multiply your n times t, and you get that, you would get 16. But you can also plug it in as 12 times 5. Just don't forget to plug it in as 12 times 5, okay? And then, yeah, you can just plug that in and click enter, and you should get the correct answer here, okay? So after 5 years, there will be about $1,859.97 in Luciana's savings account. Questions about this? Anything we're confused on? Any piece of this equation that we want to go through again? Yeah, Joshua. Yes. So if my percentage rate, now this is an absurd interest rate, but if you look down here, I'm going to write it down here. If my percentage rate was 235%, where technically is my decimal right now? We don't put it in, but it's always going to be after the, what'd you say? Not in front of the 2, it's behind the 5. Technically, it's right here. So then we're going to take it over. So what I would plug into my equation would be 2.35. Does that make sense? Okay. Yep, so I always go 2 over. All right. Questions about this? All right. Can I go to the next slide? Okay, perfect. All right. Should make sure I go on time. We're going to have you guys do the check, which is right underneath that, actually. It says if Aisha deposits $500 in a checking account that pays 0.9% annual interest, compounded twice a month, what will her account balance be in 25 years? Let's go through real quick and pull out all of our pieces. What is P? 500? Why can I not write? Oh, because I'm writing in white. That makes sense. $500. What is R? 0. What? Not just 0.9. We have to move. 0.009. There we go. Sorry. What is our next piece is N. So it's compounded twice a month. How many periods in the year are we going to have? Yeah, 24. We'll have twice a month, 2 times 12, 24. So N is going to be 24. All right, and then what is our T? 25. All right, I'll give you guys about 3 minutes, maybe less than that, depending on how you guys do, to work on this and figure it out on your own. Okay. Oh, I see. remember. Yeah. Gosh, did you get it? All right, everyone good? Okay, cool. What did you guys get? Yep, $626.13. Okay? So if we look at how much she deposited, $500, she has a really small annual interest rate, right? Even though it's compounded twice a month, if she were to just leave the $500 in and not mess with it, after 25 years, would you say that's a huge amount she gets after 25 years? No, not really. For interest, I will say, for interest on a checking account, $126 is a lot. But after 25 years, that's a long time, right? So 0.9% annual interest rate, that's pretty good. But again, you have to look at the time, okay? And obviously, she's probably going to be continually like putting more money into this account. And the account's going to continue changing, right? So she might end up having actually a lot more if she were to deposit like $500 every month into that account, right? But that's a little bit more complicated than we need to go with compound interest. So yeah, we're not gonna mess with that. But does that make sense? So again, this is gonna be very applicable because some of you guys might have a checking account right now. Some of you guys might have a savings account. Okay? You'll definitely have one after you graduate. So you're gonna want to look at your annual interest rate that your bank gives you, okay? Okay, cool. So we have, okay. If you flip back to page 367, kind of going all over the place. We're just really not in order today. This is the check on page 367. So, do we? Sorry guys, give me 1 second. We didn't really go over this equation, and that's partially my fault just because never mind. We're just gonna do it together though. Okay. So the moment you drive off a car off of a dealer's lot, it begins to depreciate or lose its value. In 2017, the average price of a new pickup truck was $41,000. You can use an exponential function to model the value of a pickup truck over time. So if the value of a pickup truck depreciates by 9% per year, write a function that represents the value of a new 2017 pickup truck at Y after X years. So all we're doing is writing the equation. We're not going to actually solve this one. So looking at can you guys tell me what our equation is? Or our original like standard form equation. A equals, wait, just with all the variables in it. Don't plug anything in yet. P. Yep. Plus, it's in your book. R over N to the what? NT. Okay? And then in this instance, it's asking us after X years. And so our X is going to be equal to N times T. But there's one thing, sorry, let me rephrase that. X is equal to N. Or, yeah, sorry, thank you. T. What is our N equal to in this equation? It says it depreciates 9% per year. So N is equal to what? Not 12, per year. And we look at compounded annually. So it's 1, yeah. So N in this instance is 1. Okay? That's why over here they just have X, okay? Because this is supposed to be N times T up here, which is just X times 1. I put that in the wrong place again. 1 times X. So it's just X. Does that make sense? Yeah, no, maybe? Okay, cool. All right, so what's our principal? You said it, Joshua, earlier. 41,000. Okay? And then in here is going to be 1 plus R over N. What is our R and our N? What is R? What is it? Yeah, at 9%, but we got to change. Yep. So this is going to be R equals 0. Ah, shoot skis, guys. That's my fault. So in this instance, this changes a little bit. We're doing compound interest for like a savings account or loans. We're going to keep adding on the money every month or every year. Does that make sense? In this instance, depreciate, which means to lose its value. So the money or the amount this truck is going to cost after like 5 years is going to be less than 41,000, right? We don't know how many less yet. But that means in our equation down here, this is actually going to be 1 minus R over N, okay? So the way to know if it's 1 plus or 1 minus is by looking at your word problem and figuring out if your, what would be some keywords? If it was addition, you're going to look at, what did the last one say? Increase, yeah, gain. A lot of accounts are going to be doing addition. You're going to be doing addition. When you're looking at things that over time they're going to lose their value, like cars, homes are going to lose their value typically, that's when you know it's going to be subtraction. Okay? So the only difference between this problem and the last problem we did is if it's addition or subtraction. Make sense? So what do we know our R is again? It 0.0, yeah, 0.09, because it was originally 9%. If we go over to decimals. So 0.09 over what? What is our N? 1. Right? So, when we, nope, not what I wanted. Subtract these, 1 minus 0.09 divided by 1, what do we get? Plug in your calculator. Yep, 0.91. And that's what's going to go here in our parentheses. Okay? Does that make sense? And then part B asks us, after how many years will a new 2017 pickup truck be worth only $20,000? So I don't think I put this on the slides, but I want us to logically think about this. If it wants to know when it will be equal to $20,000, looking at part B, right, 20,000, yeah. Where would we plug that into this equation, and what would we be solving for? If you look at the question, it'll kind of help you key which variable you're asking for. After how many years? So are we solving for y, which is the value it'll have after x years, or are we solving for x? X, right? So we'd be solving for x. So where would 20,000 be plugged in? Yes, 20,000 would be plugged in for y. And then you would solve. I remember when we have to get same bases and all of that, we would be doing something like that. Does that make sense? It would just be, no. It would just be a really gross equation that we would not want to deal with because it's an exponential equation. Okay? Does that make sense? Everyone good with that? Okay, perfect. I just want you guys to be able to know, like, okay, if I were to plug these, where would I plug these pieces in? Does that make sense? All right. We have 57 minutes. Perfect. Okay. Are we feeling okay about plugging into the calculator? Yeah, okay. I feel like you guys are doing well. So I just want us to go through this and set up the equation. Remember which pieces are which. So it says Mr. Fernandez deposits $60,000 into an account that pays 2.5% annual interest compounded quarterly. By the way, this is number 14 in your practice section if you want to go do it there. Or you can do it on the side in your like notes section on the side if you want somewhere, okay? And like put number 14 next to it. All right, so A. We know A equals blah, blah, blah. We'll figure that out in a second. So what will the balance be after 20 years round to the nearest cent? So what is our principal? What did you say? 5,000? 60,000, yep. Our principal is 60,000. All right, and then we got 1 plus. All right, and then what is our R? 0. I did not make my parentheses large enough. There we go. 0.025. Yeah. And then we divide it by n. What is our n? You said 20? What would 20 be actually? You think it would, what'd you say? Say that. Sorry, I remember. What'd you say?
So since it's quarterly?
Yes.
In a quarter of a year?
Yes.
Do you do 12 times 3?
Not 12 times 3. This is going to be, I'm just now realizing that, yeah, we don't do, did we talk about doing compound quarterly? Sorry, I can't remember. Did we talk about doing compound quarterly or not?
Quarterly's good too.
Okay.
How many quarters in a year?
Yeah, like if you divide 12 divided by what?
4? 12 divided
No. How many quarters are in a dollar?
by 4.
How many quarters are in a year?
4.
4.
Yeah.
Your N is 4.
Okay.
So,
So it's how many times per year are we doing the thing?
Okay.
So what's our N?
4.
Okay. And then what's our, well, we know our N. What's our T?
20.
20, yeah. And then what would our N be if it was compounded annually? 1. N would be 1. And then what would it be if it was compounded weekly? How many weeks are in a year? 52. It's a large number. But yeah. Does that make sense? What'd you say?
It's actually 52.
Yeah. Yeah, it's actually 52. Yep, 52 weeks in a year. So if it was compounded weekly, it would be 52. Now this is absurd, but if it was compounded daily, how many days are in a year? 365. Trying to think of other questions. If compounded daily,
I
weekly.
would say, we can give any sort of timeline for that.
Yeah.
It's up to banks to choose how they compound like that. And we'll get, as we go more and more into it, there is a limit on how small we can go. So we can do annually, we can do monthly, we can do weekly, we can do daily, we can do hourly, we can do minutely, we can do secondly. But at some point, we start running out of space. And we'll talk about that another day.
Make
What
sense?
happens when we get it closer and closer and closer together. But we could do that and like just secondly, which would be obnoxious, because we have to figure out how many seconds are in a year. But if you're a theater nerd, you know how many minutes are in a year.
Make sense? Like, never mind, I'm not going to go into that. That could be confusing. So yeah, we plug this into a calculator and we solve for A, right? And then here, we'd make sure we want to plug in both places because N is in our equations twice. And then same thing with here. So there is that. That is compound interest. A little simpler than I made it out to be, I'm pretty sure. Probably, I think I might have scared you guys at the beginning. But yeah, it's biggest thing is analyzing the word problems, analyzing the information you're given, and determining what your principal is, what your rate is, the time, and your time frame, basically. Make sense? Okay, so your your homework problems are such listed here, which we gave to you last week. On Thursday, because we went over part of 7.2 on Thursday. So now those problems that you felt like you were confused on, or I told you you wouldn't be able to do last Thursday, you should be able to do now. Test is next Thursday, the 16th. Yeah, questions about today? Making sense? Yeah. What page is this? These would be pages 368 or 369, 371, 371. Yeah, we don't go to 372. Okay? Everyone good? Cool. All right, good job today.